Hi, I'm Maxim Lukyanov, Program Manager on Big Data team at Microsoft. I work on R Server and Spark products in Azure HDInsight service. In this video, I'm going to talk about how we can use R Server and Spark to run R machine learning models on large production-scale datasets. In open source R, execution model of R programs is limited by the size of machine operating memory. This is problematic if you need to analyze dataset of larger size. Frequently, when developers receive R programs from data scientists for production deployment, they have to recode it in a different language, which scales better. Data scientists are also limited in their ability to experiment on larger datasets. R Server solves this problem by providing large library of parallelized machine learning algorithms. The algorithms have fast C++-based implementation, which uses Spark as a computation engine to distribute computation on a cluster of machines. We released initial preview of this functionality in Azure HDInsight service in the spring of this year. And today, I'm excited to announce that of November 16, we make R Server on HDInsight generally available. In addition to that, we also released new version of R Server. Version 9.0 is upgraded to use latest version of Spark, Spark 2.0, which also provides new direct connectivity to Spark data sources. The latter is a highly anticipated feature by our customers, which connects Vault of R programs to the Vault of Hadoop data formats. Now we can run R analytics directly over data in Parquet or RC format, or even data in external Spark data sources such as Cassandra, HBase, Kafka, or Solr. There are in total more than 40 Spark data sources on Spark packages repository that are now available for you in R language. Let's take a closer look at the new features. We'll start with open source R, where we'll build simple logistic regression model. In R, it's very easy to do, because the language was designed for statistical tasks. First, we'll read data into a data frame using one of the read functions in R. And then we'll use GLM algorithms to build the model. To switch to parallelized R server algorithms, we'll replace function names with corresponding parallelized versions of the algorithms from R server. As you can see, the syntax of the function definitions remains largely the same as in regular R. This makes conversion process fairly easy. After conversion, by default, R server will run this algorithm in parallel, but only using cores of the machine on which it is running. To distribute computations or nodes in Spark cluster, we'll need to add additional instruction and set computation context to Spark. And this is where a new feature comes into the picture. Now that we are in the Spark Vault, we can also read data from Spark data sources. In this example, we instruct R Server to read data directly from Parquet file using Rx Parquet data function. We can also use Rx Hive data function to read from any Hive table and correspondingly from any Spark data source that is associated with that table. Now let's see how this looks in practice. Okay, let's get started by connecting to our R Server cluster in HDInsight. This is an SSH session connected to the edge node of our R Server cluster. It has 10 nodes. And as you can see, I'm running a Spark shell on this cluster, and the Spark is version 2.0. R Server clusters come equipped with all of the Spark capabilities, so I can combine basically R Server workloads with Spark workloads. So let's take a look what we have on this cluster. So we can do that simply by using a show tables command from Spark. So this command will show us what tables we have. So there are a couple of tables on this cluster, and one of them is called flight, which contains flight information about arrival delays and arrival times of different airplanes. So this is a particular table of interest, and let's take a look at what it contains. And small typo here. Let's fix that. So there is a few columns in this table. It's a very simple sample table. It has an arrival delay and a day of the week. So we can use these two columns to do some machine learning later on. But one first thing that is very natural for me to do is to convert this table into a Parquet format to achieve better performance. Parquet is a columnar-oriented compressed file format that allows to improve performance of data operations by an order of magnitude. So we can convert into a Parquet by using this simple snippet of code. We can specify a Spark SQL query and then use a write command from Spark to write this result of this query into a Parquet format into this file. In the process, we'll also filter some of the missing values from the dataset and overall prepare it, shape it to be ready for our machine learning workload. So let's do that. The sample that I'm working with here is a fairly small one, and it takes just a few seconds to convert the dataset. So let's notice this path in our distributed file system where this file now resides. Now we can use this path and new feature in R server to read, to perform some R analytics over this file directly from our code. So let's switch now to RStudio. So RStudio is running on our cluster, and it's one of the preferred IDEs by our developers. And you can see here a little bit error here that says that about missing certificate. This is because I'm using a pre-release version of the cluster, and obviously when we release our server, this error will not surface. So please ignore it. So now that we are in RStudio, we have an R script that is programmed to perform some simple linear regression model. So let's take a look at the code. First, we define some columns where we'll use day of the week to specify various levels of these columns. And second, we are specifying where is the location of our data is. Our server is configured to have access to all of the distributed file systems in the cluster, so we simply use the path of the Parquet file that we just created to point our server to the data. So we use Rx Parquet data function here. We can also use Rx Hive data to point it to a particular to any arbitrary Hive table in the R cluster. So second, we are specifying Rx Spark function and use it to set compute context of the R server to use Spark cluster for computation. And finally, we can use Rx Lean mode function to trigger evaluation or building of the linear regression model that simply calculates dependency between arrival delay and day of the week. So let's run this code and see what happens. Now that we triggered this execution, what happens behind the scene, our server contacts the Spark cluster and creates a Spark application to perform computation on the distributed set of nodes. Let's see what happens on the Spark cluster. To do that, we'll switch to a Yarn Manager UI. And here we can see that our cluster first have 10 active nodes, and it runs several applications here. One of them is our Spark shell that we just used to do some conversions. And second one is just accepted application, the new application that runs SparkR. So that's the application that our server created. And you can see that this application has received all of the resources of the cluster and now running computation in a distributed manner on these 10 nodes. So if you switch back, we can see the progress of the calculations. And now it's complete in 6 seconds because the data set was fairly small for the cluster of 10 nodes, and we can proceed with using this freshly computed model. So first, we can build a summary of this, take a summary of this model where we'll see all of the coefficients that were evaluated, and also we can use built-in RStudio functions to visualize this model. So let's see a chart of dependency between arrival delay and the day of the week. And this is a small sample, so it has some interesting fluctuations of the data, but that gives you an idea of how we can use our server to distribute computations on Spark and share access to the practically any data set that is available in Spark ecosystem. You can now directly perform your R analytics over those data sets as well. So that was the demo based on the RStudio. In addition to that, if you're a Visual Studio person, we also have a plugin, RTools plugin for Visual Studio, which basically gives you a first-class experience of programming in R inside of the familiar Visual Studio experience. And one of the features that the RTools for Visual Studio supports is connectivity to the R server on HDInsight. So that gives you a great flexibility of using your local machine to perform your programming and then submitting your R server, your R jobs to the cluster of to the distributed cluster to perform some heavyweight computation. And in this script, you can see how we can configure your R script to connect to the remote HDInsight cluster by specifying name of the session that you need to configure in PuTTY to connect basically through SSH tunnel to the HDInsight cluster. More details on this configuration are available in our documentation website. Okay, let's recap. In this video, we looked at the new R server on HDInsight and how it integrates with Spark. We looked at the core feature of R server, which allows you to run all R algorithms in production on large datasets without recoding them in a different language. And we also looked at one of the new features, which connects all algorithms to data sources and data formats in Spark and Hadoop Vault. If you'd like to learn more about R server, I can recommend recording of the more detailed R and Spark session from Microsoft Machine Learning and Data Science Summit. And of course, documentation on the R server on HDInsight is always available for you from this link. Thank you for watching this video and have a great day.